Just as long as you can get this phone to power on and extract the data, fans are willing to pay 5,000 renminbi. After hearing from the fan how this phone broke, I believed this promise. The fan said on the weekend, he went out for barbecue with a few friends. Afterwards, everyone drank quite a lot. In the end, they were competing to pay. Not only did he fail to grab the bill, he was also pushed by his friends and fell down because the payment counter was at the stairway on the second floor. He fell down and hit the stair railing. Then the phone fell from the second floor to the first. He didn't pay the bill for a meal, but ended up spending over 10,000. This is really unbelievable. We inspected this phone. The screen was not cracked. The frame also had no obvious damage, but upon closer inspection, a problem appeared. The integrated camera frame was actually cracked. It seems the phone was in a case at the time of the fall. No surprise. It likely suffered serious internal damage. The fan said after the fall, he had it checked at a local repair shop. They said it was not easy to fix. Then he saw our video and sent it to us. After we disassembled it, we found the internal display shield was not installed. We first removed the screen and battery shield, then used a power meter to test current leakage. We found the motherboard was leaking 400 milliamperes and could not power on. Okay, we continued removing the mid-frame shield. Now everyone can see how serious the internal damage is. The internal metal frame and battery were completely crushed and wrinkled. The iPhone 17 Pro Series motherboard is horizontally designed and very small. Apple also uses a Huawei-like black armor structure design to protect the motherboard. So to damage this motherboard, the impact must be extremely strong. After removing the motherboard, we found it was severely deformed. It seems this money is not as easy to earn as expected. The current state is leakage. We measured with a multimeter to narrow down the fault area. First, we tested the first terminal of the battery connector. The resistance was normal. Then we tested the capacitor near Wi-Fi. This is the second stage power supply after charging IC conversion, and we found a 0004 short circuit. So the fault doesn't seem that large for heavily dropped phones like this. It is often just a single chip failure. How do we locate it quickly? We use a thermal imaging camera. Unfortunately, the thermal camera did not accurately locate the issue, so we had to heat the board in separate layers for inspection. After heating and separating layers, we found many solder pads had fallen off. This is a huge repair job. Even the shielding frame is deformed. The grounding points have fallen off. After separating the two-layer motherboard, we tested again. The logic board power was normal. Then we tested the other half separately. The short circuit was indeed on this board. The missing inductor was exactly the second stage main power supply. We first soldered a wire to reconnect it, then powered it on separately. Thermal imaging showed the IC was heating up. We removed the display IC. The short circuit still remained strange. We checked again with thermal imaging. The real issue was actually on the back side, under the shielding cover. It was the display power supply SA chip. We removed the shield and found the chip. After measurement, resistance returned to normal. We reinstalled the display IC. Next, we repaired the missing solder pads. According to the board diagram, most were ground points. Only dozens to under 100 were functional lines. We used a blade to scrape out all broken pad traces one by one. Small pads required jumper wires. Actually, this job isn't hard. It just took a day. Some larger pads were restored using solder paste and reflowed into solder balls. Finally, we reinstalled the missing inductor and another display power chip, otherwise the screen would not display. Then we cleaned the other layer's pads and reballed the solder. We aligned and bonded the two motherboard layers. After cooling, we tested with the power meter again. There was still slight leakage, but the phone could power on. We ignored it. We only needed the data. We installed the screen again and tested power on. The screen lit up. Then we assembled the phone back into the housing, tested again. Okay, the phone powered on successfully. Data is saved. We can get paid now. There is slight screen leakage. We ignored it as long as it displays. It's fine. The password was not provided by the customer. The data is very important, so we will send it back like this and let him handle the rest. Okay, done. Collect payment.